Primary key and unique keys define integrity and consistency rule for the data stored in any database tables. Snowflake provides support for primary key as well as unique keys as defined in the ANSI SQL standard, but does not enforce them except for not null constraint, which are always enforced. Then why Snowflake provides support for primary key and unique keys when it cannot enforce? The primary intent for it, the constraints are supported primarily for data modeling purpose and compatibility with the other databases if you are having a migration project, and as well as to support client tools that utilizes these constraints. For example, the popular BI tool Tableau support using constraint to perform join elimination, which can improve the performance of generated queries and queue refresh. So let's understand how we can define primary key and unique key in the Snowflake tables, how to track the table properties to check if these tables are having primary keys or unique keys using different SQL command. Also understand the impact of data loading with primary key and unique key applied in our table and other challenges while building ETL solution when these keys are not enforced by Snowflake. Back to my channel Data Engineering Simplified. Everything covered in this video can be tried out with Snowflake's free trial edition. It grants all full privileges and enables all the features. If you have any technical questions, need architectural advice, or want guidance on starting or migrating Snowflake project, don't hesitate to reach out to me on my Instagram account. You can also join my exclusive Facebook channel by scanning the QR code to request access. So let's start with a very simple example of employee table. I'm in my Snowflake Snowsite web UI, and this is the context. So I'm using demo database, public schema, and system admin role. This is my employee table, and it has ID, first name, middle name, last name, and so on. Let me create this table without having any primary key or any unique key, and let's see how does it look like. So my table is created successfully. Now, when I describe this table, this is my primary key column where all the values are known, and this is my unique key column where all the values are known. What it means that I do not have any primary key or any unique key available in my table. I can run the show primary key command on my account, database, schema, or table. Since I have only one table available, let's run this command. I don't have any primary key available in my schema. Now to add a primary key in your table, you can use the keyword called primary key. Let's recreate the table. So my table is created and let's describe it. Now I can see my primary key flag changed from no to yes. Once I enable the primary key for my ID column, the not null flag becomes true automatically. Now the next question, can I define multiple primary keys? Let's say I would like to add email as another primary key. Can I do that? Let's try to run this DDL statement. It says you already have a primary key in the table, so you can't define that. We will see how we can define a composite key in the later part of this video. Now, when I try to run this show primary keys in schema demo.public, I got one entry. Employee 00 has a key defined and it also added a sequence number, and the constraint name is given automatically. Now, if you do not like this constraint name, what is the other alternative where I can specify? Because with this, the constraint name is not possible. So for that, I am going to follow a different approach. I'm going to define a table called employee 01. I am executing an alter statement on the table called employee 01, and using keyword called add constraint, I am specifically giving a name to my constraint called EMP primary key, and then using the keyword called primary key and specifying the value ID. So let me run this alter statement. Let's describe the table. I can now, this is a primary key, looks good, and here the value is still yes. Now let's run this show primary key command. This is how my data looks like for employee 0 table and employee 1 table. In both the tables, I have ID as a primary key sequence is 1, and my constraint name is EMP primary key. So if you have a requirement where you would like to specify the constraint name as of your choice, then alter statement would be more appropriate to define. One of the strange thing here, the null value is yes and primary key is also yes. But if I change this to employee 0, this is no and this is yes. But when I use primary key as an inline keyword here, it automatically run two alter statement. One, attach a primary key constraint, and second, attach a not null constraint to the table. This is what my observation, and I assume so when you are building your ETL solution, and if you're not too much worried about the primary key naming convention, probably you should attach the primary key keyword directly with your primary key column. So we have understood how to define a primary key by having an inline approach. We have also understood how to define a primary key by having an alter statement. Now we'll quickly see the third approach. So let me remove this keyword from here and I can give a comma. So this is another way you can define a primary key in a table, and this is very common in many other databases. Let me execute this DDL statement. It got executed. Let's check show primary keys. So my primary key is defined. So this is another way to define a primary key in your table. So we have seen three different approaches to define a primary key. In the first approach, the primary key keyword is directly attached with your primary key column. In the second approach, we have not attached the primary key keyword with the column. And the third, we have used the alter statement to define the primary key. The approach 1 and approach 2 produce exactly the same result. In approach 3, not null is not enforced. However, the primary key constraint is defined. In practical terms, there is no significant difference in the outcome or the functionality of the table created using either of the approach. Both approaches will define the primary key for the given column, in this case ID. The choice between approach 1 and approach 2 is often comes to a personal preferences and coding style. Some developer prefer to define constraint separately for clarity, other prefers inline approach. Let's talk about another situation where we have to define multiple keys as a primary key, that is also known as composite key. Let's assume I would like to define ID as well as email address as my composite key. I cannot attach primary key keyword with these two columns. If I try to define multiple primary key text with more than one column, my DDL creation fails with an error. In that case, I can use a different approach. And let's create my employee 02 table. My employee 02 table created successfully. Now let's describe my table. And if you look, row number 1, primary key yes, row number 6, primary key yes, and here my not null values are also defined as a no. So you cannot insert not null, and Snowflake will ensure no null values are inserted or copied to these columns. Let's see what result does this statement bring. So if you look into the employee 02 table, I have two columns which are defined as a primary key, and key sequence is 1 and 2. So now you understand what is the meaning of key sequence. If I flip the key sequence, then it will change from 2 to 1 or 1 to 2 or vice versa. My constraint is defined automatically and the constraint names are same. Now if I just add SSN here, let's say what happens. Let's give SSN as a first. So my SSN is my first key sequence, ID is second, and email is third key sequence. This is how you can use primary key keyword, which is not in line with your column name, to add a composite key. Next, we are going to understand how to add a unique key. For example, I have this email field which should be unique in the employee table, or the SSN number should also be unique. In that case, I can use a keyword called unique. Okay, if I just say unique key, let's see what happens. So it failed with an error. It says that unexpected key. So I cannot use the word key. Now let me rerun this. So it has been created successfully. And let's describe the employee 3 table. And if I look into the email, it says it is unique, and but it is not a primary key, and null values is still supported for this column. Looks good. Now if I run show primary keys, does it bring the unique values? So employee 03 is having primary key, but it does not have a unique key. Let's see if I can run unique key. Yes, you can have unique key. So I can run a display unique key where it will show what is a unique key, and it also has a key sequence and it gives the name automatically. Good. So if I have to define multiple unique key, let's say email and SSN should be the unique key. And if I rerun this command, it is created successfully. Here, both the values are tagged as a unique key. Looks good. Along with unique key, I can say not null. Let's see in which sequence I have to specify not null. So now null values are not allowed as well as their unique key. Looks good. Now if I run this show unique key in schema, I have got 2 unique keys and sequence is 1. Looks good. Now let's try to define unique key through a different approach. I will remove the unique keyword from here and just add a unique keyword. And just change this name to 4 and let's see what happens. So it has worked, and let me run this statement. So in this case, the sequence number is changing from 1 to 2. Good. So this is how you can define unique key as well as primary key attached with a table. Snowflake allows to define primary key and unique key, however, they do not enforce. And by considering that, this two definition really does not make much difference. However, if you take the second case, in the first example, uniqueness is enforced separately for each of the email and SSN columns. This means that each column must contain unique values individually. In the second example, the composite or a multi-column unique constraint is applied to the combination of email and SSN column. This means that while individually email or SSN values may not be unique on their own, the combination of email and SSN values across all the rows must be unique. And we would see how Snowflake behaves when we try to insert record into the table, which violate this integrity or a constraint definitions. Let's load the data into my employee 05 table, and then let's see how does it behave. So I am going to create a table called employee 05, and let's see how does it look like. So this is my primary key. It does not allow null values. My first name and last name also does not allow null values. My email and SSN are unique values, and they also do not allow null values. So if you look into my definition, these are my not null columns, and on the line number 21, I have given variable pay as a default value, and let's see how does it look like. If you go to my variable pay percentage, by default it is 0. Okay, so if you do not specify any value, it will take 0 value. Now let's run my show command. So my employee 05 has 2 unique values, email and SSN. Looks good. And let me quickly check. So my primary key is only ID. All good. So I will load the data using my Snowside data loader feature, and then I will try to insert duplicate or non-unique values inside the table and understand the behavior. So this is my table, and if you look into this table definition, here it has already converted. This is primary key, this is unique key. All the not null values are available here. So if you look into this, this is not null, and this is my primary key definition. Looks good. I click on this load data and browse my data. So this is my employee data table, and I click on next. I say skip my header, and let me show how the data looks like. File. This is my data file, and I have total 100 records. Looks good. The ID start with 10. I have all the necessary field available. Now when I click on a load, so 100 rows loaded successfully into the table. Okay, click on done, and let's click on a data preview. I have total 100 rows, and I have ID up to 109. Looks good. If I click on a copy history, so it says data just loaded, and total one file loaded. Now let's run select start from employee 05. So this is how my data looks like. Let's take this ID 12. How many record do I have with employee ID 12? I have only one record available. Good. Now I'm going to insert a same value having a duplicate employee ID, and let's see what happens. So one record got inserted. Okay. And I can see my employee ID 12 got inserted. Looks good. And even my email is duplicate and SS is duplicate. So the uniqueness definition is in place. Primary key definition is in place. However, it is not being enforced by Snowflake. So what does it mean? That you need to have a manual enforcement when you are running your ETL program. So this increases complexity in maintaining your data consistency, and that is one of the biggest challenge we have it with Snowflake. And this also impacts your performance and storage overhead, because you need to run additional queries to make sure that there is no duplicate record available in the Snowflake tables. And there is a high possibility that if there is a bug, you will get a lot of data duplication, and the data duplication will have additional cost because you will consume additional data storage. Let's say that if I try to give null SSN, what happens? It says null result in not nullable column. Okay. However, if I try to give this null value to my this part and bring this SSN number back to normal, this will go through. So here I have a null value. However, rest of the columns are having the data set. Good. Let me show you the interesting result from our query profile based on the different operation we have performed so far. A create table is a metadata operation, but when you go to the query profile, the step is called create table. When you describe a table in the query profile, the step is not registered because it says some queries such as those with use and describe statement have no query profile. When you run show primary key or show unique key command, the query profile registered as a metadata operation. Alter table is registered as an alter table step. Drop a table is registered as a drop table step. When we load the data via Snowside data loader, internally it runs a copy command, and this copy command is registered with multiple steps. It runs external scan, insert, and the result. When you run insert statement, it also registered multiple steps. And this is an interesting observation. Even though our SQL failed, it has generated multiple steps and it has taken some time to complete it. So what we have seen that you can define primary key, you can define unique keys, only not null is being enforced. Unique key and primary key constraints are not enforced. When you are migrating your project from legacy to Snowflake or you are building a solution, you need to manually enforce primary key and unique key constraint. I hope you have enjoyed this quick tutorial. Learn a lot about Snowflake primary and unique key constraints. Snowflake tables hold many key insights. To become a Snowflake Cloud Data Warehouse Pro, make sure to catch all the videos in this playlist. Thanks for tuning in to this quick tutorial. If you have found it valuable, hit the like button. By doing so, YouTube will serve up more Snowflake content from my channel to help you on your Snowflake learning journey. Happy learning and keep on growing.